As Chris alluded, my name is Micah Godbolt. I'm a front-end developer for a Drupal shop out of DC called Phase 2. We do all sorts of large-scale, usually media groups. I've been actually working with Red Hat for the last couple of years, working on their redhat.com, getting that up and going. You can follow places like myself on Twitter, which I just tweeted out the slides to this deck. So if you want to follow along there, you just have to go to my Twitter. I thought that's a good little carrot. I also do this thing called SAS Bites. It's a weekly bite of SAS during your lunch break. I've practiced that many times. It's usually 10 to 15 minutes talking about something SAS, front end, whatever kind of thing. I've actually been doing, I also do some interviews on there. Some people in this room I've actually interviewed. And going through a series right now where we're interviewing all the speakers that are going to be at SAS Conf this next month. So get a chance to introduce them and their talks, and there's actually some of them here as well. So that's kind of a fun little thing. Also run this little thing called PDX SAS out of Portland, where we meet typically once a month and talk about SAS and front-end things. So if you're in Portland, hit that up for information as well. For some crazy reason, I also decided to write a book. I can blame Chris for that one as well. So if you're interested, you want to know more, frontendarchitecture.info or fea.pub. It's a whole lot easier to type if you're on a phone. I'll give you that. You can actually purchase the early release now through O'Reilly. It should be out in December or January, depending on how the editors are nice to me or not. So the topic of today is getting started with visual regression testing. Is there anyone right now that is currently doing visual regression testing on their current project? Hands? Wow, okay, so we're going to... You're like hiding over there, Kevin. I can barely see you. Okay. Peanut gallery. So visual regression testing is still a pretty new topic. The technology is still pretty much in turmoil. New projects are coming out and get deprecated as quickly as I can write talks for them. But it's a very, very important area, and I want to give you a little introduction as to what it is, how it works, how to get started. We'll even dive into some code examples. You can see how it actually works on a project that might look something kind of like yours. So how does visual regression testing actually work? What are we testing? Are we testing functions? Are we testing people clicking on a page? No, what we're actually testing is we're testing pixels. We're taking kitten A, comparing it to kitten B, and finding out the kitten hasn't changed, but the title underneath that kitten has changed from lowercase text to uppercase text. And we can see that on the third image, the diff. So the way that visual regression testing works in pretty much any place that you run across it, there is a tool typically like ImageMagick or something like that that's going to take two images and basically find if there's a pixel difference between the two. It's not looking at CSS properties. It's not looking at anything that the DOM is representing except for the pixels on that page. So there it's picking up the fact that this is my teaser title has changed, and it throws back an error, and then you're able to do something based on that error. So of course it's like, okay, great. What do I do with that? That's all nice and dandy. There's a couple ways you can fit visual regression into your current workflow. One is comparison. We can compare kitten on the left with kitten on the right. While they might look similar, one is obviously larger than the other. So oftentimes what we will do with visual regression testing is use it for comparison. We will take two things, kittens, websites, they're about the same thing, and we'll compare those two. Whether it's going to be, say, a feature branch with your master branch before you merge those two things in, or maybe your staging server compared to your production server. So what we can do is go in and take snapshots of pages and compare those snapshots to see if things have changed. I'll have a little example of that here in a little bit. The other thing is visual regression testing, you can use a baseline approach. And with the baseline approach, what you do is you take a snapshot and you capture that as your baseline. So our baseline is a lion. That's what we're shooting for. That's what the client is expecting out of our product. So every time that we run this test, we should get that same result. This is a little bit more traditional if you do any JavaScript testing, functional testing, end-to-end testing. You do something over and over again, and you expect the same result out of it. And that's the approach with baseline. So we can compare, so you've got a widget on a page. we can compare that widget from our feature branch to master, make sure that widget's the same, it hasn't changed. Or we can also do that again from, say, like staging to production, just to make sure that what's actually currently live will be what gets pushed out as well. There's no differences between those two things. And we can do that through some kind of baseline image. So we can say that we're expecting that big, nasty, gnarly cat, and if we get a kitten, something's wrong, something's rotten in Denmark, we need to go back and fix it and address that. So getting this in your workflow looks something like this. So when you're working with some kind of comparative approach, you might have your production server like on the left-hand side. That's a screenshot I just grabbed earlier today from the Phase 2 website. And if your development server comes up like this on the right, that's usually a bad sign because I went in and deleted some nodes and changed some CSS. It's usually something breaking. So with visual regression testing, we can run this test over and over and over again, where with production and development, typically you're going to pull the same database, run the exact same code, just it has the new updates to it. And if we find this, visual regression testing will quickly and easily spot this difference. Even if everything is there, everything is functional, you can still click on the nodes, you can still interact with the page, no tests are failing. Visual regression testing is going to tell you those are two very different pictures. And that's going to throw a big red flag before you push out some code to your front page that breaks everything. On the other side, if you're doing more baseline testing, one great place to do that testing is actually within your style guide. These are a couple images that are from the, and I just totally blanked on it. If anyone recognizes these, please tell me what it is. It's, I just grabbed them. It's a great UI style guide, and I'll tweet the link out because I should give credit to them. Rizzo something or other. Is that ringing a bell? No? What is it? Lonely Planet. Thank you. Lonely Planet. So these are grabbed straight from their style guide. A public style guide anyone can get to. And it's a really, really great example of what you can do with style guides, and especially integrate into their systems. But the great thing is, these are style guides that are static. They look like this with the same classic Paris, a fresh look of the city, every single time someone goes to that style guide. That content never changes. This is a great opportunity to do some baseline-based visual regression testing. So for every single widget they have on their page, whether it's a slider, whether it's a map, whether it's various types of image embeds, those can all be captured as baseline images so that every single time they push new code out, they can run their tests and make sure that none of those kittens, none of those lions are looking like kittens. So style guides are certainly one of the greatest places to be able to do that type of testing. So when you start getting to like, yes, I'm sold. How do I get started? What do I do? Well, there are a lot of tools out there that will get you going on the road of visual regression testing. And they often fall into a couple different camps. They have different features that often fall into these 5 little areas I've come up with. There's typically a difference between there's a lot of page-based tools versus component-based tools. A page-based tool will specifically just take a picture of the entire page, whereas component-based will allow you to take, well, page element if you want to, but you can also drill down to individual IDs, classes, even complex CSS3 selectors. So when you're looking at a tool, check that out, what kind of capabilities they have. If you're just doing some comparison testing, page-based might just be perfect for you because you want to check the home page versus production and staging every single day. You don't care about selectors, just check the whole thing. But if you're doing a style guide, you want to be able to do diffs on individual elements because if you change the composition or the arrangement of those elements on the page, you don't want your diffs to come back failed just because the order on the page changed. So being able to do component-based is really important there. Comparison versus baseline, we kind of already talked about that. If you're looking to do a baseline approach, make sure that the tool you're using supports that. Headless versus desktop. Are you familiar with Phantom.js? Yes, Phantom.js? Cool. All right, so that's not too crazy. Phantom.js is a headless browser. It's a WebKit-based browser that is headless. There's no actual UI to it. But what it allows you to do is execute HTML, JavaScript, CSS within a browser and then interact with it, whether that's performing tests on it, taking screenshots of it, those types of things. The great thing about it's extremely stable. It's extremely consistent from platform to platform, and it's extremely fast. It's made for testing. It's not made for rendering and looking nice or interacting with or something. So that's headless. a lot of tools allow you to work with desktop browsers, typically through something like Selenium. So Selenium is a Java-based application that will allow you to actually manipulate browsers on your desktop device or laptop device, or actually mobile devices, so that you are actually performing your tests on real browsers. Challenge there is often, though, okay, browsers change. Browsers from one platform to the next can be different. So if you are doing that, you want to make sure you have some consistent environment. And something like Sauce Labs or Browser Stack helps with that as well. There's also some diffing tools that will have a GUI. They'll actually have some kind of UI where when you have diffs, it will walk you through, here's your 7 diffs, check yes or no, swipe left or right kind of thing, if this is an acceptable one, or if this one should be tossed back and they should fix it. But most of them you'll find are actually just command line based. They run just like any type of unit tests, where you run the test and it returns back a pass or fail and brings the information back to it. A lot of them will work with Jenkins and Travis CI, and even spit back the reports that are specifically designed for those tools as well. The fifth one is kind of a catch-all. Oftentimes they'll have different things. Like I've seen some that have actual CSS unit testing that will actually test the CSS values on the page as they're calculated. So like that H1 tag, what's that actual finished pixel size? What does it come out to? You can actually test that and make sure that's consistent. So that if you have M stuff going on, or just things are nesting, you want to make sure values continue to come out the same, you can do that. And there's also the idea of having scripting libraries. A scripting library allows you to interact with the page more than just a selector, to be able to click on things, to be able to move the mouse around or input text into fields. On the Phantom.js side, Casper.js was a really great option for this until Phantom.js 2.0 came out, and Casper might get deprecated unless someone really wants to jump on board and fix it, please. But that's the joy of open source software. But that's one example, Casper, and actually we're going to show you some examples of what Casper code looks like. Another great example of that is WebDriver.io, which is based on Selenium. So it's actually Node.js bindings that allow you to interact with a Selenium-controlled browser. So instead of having to write all your tests in Java, which I know we don't want to do, you can write them in WebDriver.io, and that is all JavaScript, it's all Node, it's all obviously a little bit easier for us to parse. But it does the heavy lifting of telling the browser what to do. And if you are coming to the Visual Regression workshop on Wednesday, those are the tools that we're going to be diving into pretty heavily, so you can look forward to that. And if you're not, you should. I think there's still room, right, Chris? Excellent. You can still come. All right. So let's move on. The first thing we're going to talk about, one of the tools is called Wraith. And this isn't actually completely accurate, because Wraith has grown since I started doing this. They're a preliminary page-based tool, and then they added on the features to be able to do component-based. They were originally a comparison-only tool, and then they had the features to do baseline. So Wraith actually is getting a lot more multi-purpose, but in its heart, it started as a page-based comparison tool. It definitely uses Phantom.js for the browser, and it's very command-line heavy. So that's the one we're going to start off with and give you an idea of what that looks like. What we're going to be taking a look at is back to the Phase 2 website. I stole a shot of this. This was several months ago. We've apparently updated the website since then, which is why I grabbed it local, so I don't lose out those assets. What we're going to do is compare 2 versions of our website, basically like a production versus development kind of thing. For the most part, you don't see any problems. Get down a little further, though, we notice that we've updated some content. So we've got a blog roll there with the top 3 most recent blogs. And, well, obviously, if you're doing visual diffing, what happens when you have new content come in? Well, yes, it visually changes because there's new content, new images, and those kind of things. You also see changes like that between below news and events. That text got a little bit bigger. Somebody fat-fingered some CSS, and now we have some different styles applied to that. We've also got something messed up here in our Get in Touch, where the colors changed, should be black, changed to white. Those are some of the changes, at least the obvious changes, that we're going to be testing for. Ooh, and it is now demo time. So first thing I want to do is just give you a quick look at what Wraith looks like. The nice thing about Wraith is extremely easy to dive. Wow, okay, I'll stop that. It's really easy to get into. It's all YAML-based, so if you ever worked with YAML, it's a very simple language to read, to parse, and to write. There's not a bunch of syntax to it besides a tab and a dash here and there. So you can see that we're using Phantom.js for a browser. The snap file is some JavaScript that helps it run. You can make some modifications there. We can specify the directory where the images go. We can specify our new versus baseline. So remember, we can say, we want to compare two sites. So those are the two that we can compare there. And I think you can actually compare more than two sites now. They've added that ability. We can also just easily add additional screen width. So if I want to add 640 into this mix, I just have to type 640, and we're now also testing the 640 screen width. If you want to add paths, I just have a single path because I'm just doing a single page, but that's as easy as blog is the blog URL, and I don't think you might need that anyway. But adding additional pages, adding additional screen widths, adding additional domains is extremely easy with YAML. There's not a lot of JavaScript to break. So this is a really good introduction, something to get into if you're just wanting to start using some visual regression testing. So let's see it in action. So Wraith capture, and then you just tell it the file, the YAML file to use. It's creating some folders. It's snapping on those pages. It's cropping the images, saving diffs. And we've got failures detected, which is a good thing because we're diffing two things we know there's some failures on. One other nice thing about Wraith, it is a gem, which I guess might not be a great thing depending on your environment. But it does a very good job with templating. So every time that you build something, it actually makes this nice little web page for you so you can see what your changes are. So there's a template there you can hack away on if you want to, put your own brand on it, make your changes to it. At one point, I even threw some JavaScript in here because the UI is nothing fancy. But you can see here's our baseline image. That's what it's supposed to look like. Here's the new image. That's what the new one looks like. And here's the diff. So this is obviously where the real importance is. So at the top, we see that nothing's changed. Once we get down to those blogs, we see that something has obviously changed. Content has changed, but Wraith doesn't care about that. It doesn't care it's content. It doesn't care that it's not actual CSS change. It just sees the change in pixels. And that's kind of where our first problem occurs, is that visual regression testing isn't smart enough to realize that this is just a change in content. It's not actually a change in CSS. Going down further, we can see this. So we knew that text below news and events had changed. And so we can actually see there's some blue there, and you can see that we're here, and the W should be kind of there-ish. And so that obviously changed. So we caught that. That's great. Lovely. But the problem is, since that text got taller, that means that everything below it is a couple pixels lower. Sad trombone. And this is one of the problems with page-based diffing, is that if you have one problem, heck, if you make a change to your header, and your header's now 5 pixels taller, every single diff that you do is going to come back just this big blue sheet of diffs. And that's never fun. So that is one of the challenges you're going to come across when doing page-based. Typically, when you're making a change to the header, you're just going to have to accept it and understand that's coming, and maybe just like do that in its own release so that it's not, that's the only change to your code, and do other code changes when you're not doing something like that. So if you are testing the home page and you want to make sure you're not screwing stuff up, you might isolate that header change for later. But you can see it gives you a nice little UI. You can see the mobile breakpoint just as well as the desktop. Kind of the same thing going on. Lots of blue at the bottom, and that's Wraith. Gives us a really easy to set up. You can set this up within minutes on your project. This doesn't even have to be in the repo of your folder. You can set this up anywhere. I can run tests on your project right now if I've got access to those URLs. So a really simple test you can set up. You can even do the situational. I've had situations where I'm changing a specificity of anchor tags or something. Like our anchor tag, for some crazy reason, had a class and then an anchor tag. And I'm like, why? And so I want to change specificity, get that back down just to a single anchor tag. But I want to make sure it didn't break a whole bunch of stuff. So I didn't expect any changes, but I was able to go and create a single Wraith comparison test, set up for 40 pages, something crazy like that. I actually was able to pull a report from Drupal, grab all the URLs, copy paste it in, do some Sublime Text magic, and get a big huge list of them, and just ran every single page. You should expect 0 things to change. But if you find that one thing where an anchor tag is the wrong color, you screwed something up. You can go and fix that. So a really great instance use case is when you don't expect things to change, but you want to have that kind of coverage. That's what Wraith gives to you. All right, so back to Keynote. So the problem is, and we kind of saw some of the problems, we missed some things. We had some false positives. We had stuff that there's a whole mess of blue, but there wasn't anything wrong with it. It was just something above it caused that to report an error. We also had some false negatives. You remember the text lower down there had changed from black to white, or white to black, or something like that. It actually changed colors, but we didn't see that because the change above that pushed it all down meant everything had blue on it anyway. Everything was all a change. So we didn't actually see that there was an actual regression hidden inside of those changes. So if we just discount the fact that, oh, there's a change up top, the stuff below is fine, don't worry about it, we can miss those false negatives. We also had some hidden differences that we weren't able to detect with those simple tests that we had. There's also some interaction differences. We didn't get a chance to actually interact with the UI of that page. We weren't able to move the mouse around and see how the elements behaved when our mouse moved. And then the issue with inconsistent content, the fact that when you have a blog that changes or something like that, when content changes, you're going to keep running into those diffs. And to fix some of those things, I want to talk about Phantom CSS. And I did mention Casper.js, which is one of the dependencies of this, is kind of in a sad state. I almost yanked this out of it, but it's still a good demo. Phantom CSS is still a good project that the maintainer of it is looking for maybe some other technology alternatives to go with. But it's a really great example of how you can use visual regression regardless of the state of the current open source software. So the differences with Phantom CSS is it's very much component-based diffing. It's really based, like that's what it's used for. It's going into a style guide, grabbing individual pieces and doing diffs on that. It's very much set up for baseline. It doesn't even have a comparison option. First time you capture, it's going to grab baselines and keep those baselines. Any subsequent tests that has a baseline for it, it's going to compare it to that and see if there's any differences to it. So it's very much built for baseline use. It does use the same headless browser of Phantom.js, which is where all this trouble stems from. And it also is a very much command line based tool. Nice thing is it does have those extras of using Casper.js. And regardless of the state of Casper, again, it's a great library. And it's actually extremely similar to WebDriver CSS, or actually WebDriver IO, in the way that it looks and the way that it works. So it's a great demonstration of how that all plays out. So let's dive over to that demo. So I showed you the YAML file first because this is a nice, friendly YAML, really easy to kind of pull in. We're going to jump over to Phantom test now, which is going to look a lot more like, well, just the big, huge JavaScript objects. And a bunch of functions and passing things in as parameters and all that kind of stuff. So obviously, if you're less familiar with JavaScript, you're going to want to get a little more comfortable or at least tread carefully coming into here. So so I don't want to dive through all this, but we're requiring Phantom CSS up here. And then we're setting some basic initialization for where we're saving our screenshots and those types of things. And what I did is, since this doesn't do comparison, and I'm comparing two websites, I took a set of screenshots with the P2 version, and now I'm going to run all my tests against the P3 version, and that's where I'm going to find all my differences. So you'll see that code in there. I actually do have this on GitHub, and I should send that link out as well. I realized I didn't put that in the slides. So you can actually pull this down yourself and take a look at it. I don't have these new dist files in there, so let me update that. I'll tweet that out as well, so if you do want to play around with this, I can get you the code. So let's just take a look at a real simple example of how Casper works and how it captures screenshots. It's a big series of then functions. Then do this, then do that. Because you see as we're starting here, it says Casper start. And in that case, you're going to ask it, it's going to ask for a URL, and we're going to go to that URL. Basically means it's going to open up that page, and then we can do stuff. So the first thing we're going to do is we're going to set the viewport to 480 by 1200, and then we're going to take a screenshot. This is my selector for the screenshot I want to take. And the great thing with that is it's this nice little box right around that work in action selector on the page. It's going to be extremely consistent. It's geometric. It's specified by that selector. Really easy to make a selection like that. And then we can give it a name. That's basically going to be the file name that gets spit out when we're done with it. And I'll do the same thing for the 1024 by 768. So I can test a couple different sizes. Yay. All right. So we can see this run. And I get pass, pass, 2 tests pass. Lights green, trap is clean, everyone's go. So this is really fitting for the name of these projects. All right. So this is a great example of we're just taking our baseline images, we're comparing them to the new screenshot, and Phantom CSS doesn't have the fancy little UI, but we can just look in here real quick. Here's our baselines. What I do? I did work in action. So here's the baseline images that we grabbed, and here's our results. And you can see there's no diff in there, and these are the new ones. So they're exactly the same as the other ones. So hey, it passed. This component that we built is exactly the same as it was our last deploy. So that's good. We know without a shadow of a doubt the way the CSS is representing this HTML on the page has not changed. Well, that's great, especially considering that we're going to break some stuff now. So let's go down here and uncomment the next one. So next thing we're going to do is we're going to avoid false positives. So as I said before, false positives occur when you've got a change that occurs on something that has broken, but false positives, oh yeah, when it has broken, and everything below it looks broken as well. So the great thing is with Phantom CSS, since we're just taking screenshots of selectors, it doesn't matter where that selector is on the page. It can be up here, it can be down here, it can move all over the place. That selector is really all that's going to take that screenshot of, so that's all it's going to compare against. So when we do a test of that, we're going to see that we're going to get, again, we're going to get 4 passing tests, or 3, however many I wrote for this one. 4 passing tests. Because even though in Wraith we saw blue all over the place on the news list, it was only because something above it had gotten larger, which had moved it down inside of the image. So the first thing that this allows us to do is avoid those false positives. Next thing we want to do is be able to catch false negatives. So the call to action section, some color had changed in that. Yet we weren't able to see it because there's a diff above it that basically caused a bunch of false negatives, which hid the false positive. So in being able to capture each individual element on the page, we're able to test them individually and not within the context of the rest of the page. So we'll see that those other 4 tests pass, though on our, it moves too fast, our call to action, we do get a fail on those. So we can see some visual changes have occurred. We got 80% and 1.47% mismatch. So that's our call to action. So here is the image, here is the fail, or actually here's the fail, and then, here's the diff, and then here's the actual fail. So it's showing us the area that's changed is that drop us a line, would love to meet you, has changed colors. So our visual regression testing will be able to catch that even though it's been obfuscated by a failure above it. So yay, that's one more thing off of our list. Next thing, hidden differences. Now at phase 2, we have a brand. We like color orange. We use it for lots of things. So I've got a feeling they'd be a little bit annoyed if we were to make a change to the website and it was to come out like this. And of course, I have to wait for test to run. All right. Mobile nav. All right. So this is what our navigation is supposed to look like. Nice and orange. Beautiful. Love it. If it changed to this, they would probably not be too happy. Not only is yellow definitely not on brand, but that is horrible. You can't read it. You can't use it. It's not the right color. The problem is we can't test that, or we can't see that by just taking a screenshot of the mobile of the website at a mobile breakpoint, because that's hidden behind some JavaScript. So without the ability to actually interact with the page, we're going to miss a lot of these types of problems. So what we're able to do, here we go. So you see we were just doing screenshots here before, basically changing the viewport, passing the selector. We're also able to pass in these small functions, these little helper functions. This is something that is really where the power of something like Casper.js or WebDriver IO come in, allow us to interact with that page extremely easily. Where we have a click function, how easy can that be? Where all we do for the click function is we pass a selector into the click function. That's pretty simple. So for us to write this test, all we have to do is set the viewport to the size in which the mobile navigation shows up, click on our mobile control, which if you go into the DOM, you'll find that, and then take a screenshot of the website. It's the exact same state. And what we're going to find is once that mobile navigation opens up, we've got a big, huge diff there, and we need to fix that. So one of the great things about using some kind of scripting language is that it's not just mobile navigations, but carousels and modals and anything that you have to interact with, filling out a form, submitting something. I mean, if you've got an application, I mean, the initial page load is just a small part of what your application actually does and the styles you've had to apply to the application to make it look correct. So being able to write your tests where you can interact with those pages brings just a completely new world of testing. And it's at this point where like you start having fun. You're like, all right, what can I test next? Because it's so simple. I can click on this, then I enter some text in here and hit a button and do this and take screenshot after screenshot. I just created a mad load of visual coverage for my application with just a few lines of code, something that we didn't have before and it's adding a huge amount of value to our project. One more thing that we can't do with JavaScript is actually test what our page looks like as the mouse interacts with it. Not even just clicking, but hovers. And correct me if I'm wrong, but I'm pretty sure you cannot use JavaScript like you can use JavaScript. I could have used JavaScript to open up our mobile nav. You cannot use JavaScript to invoke a hover, correct? Like if you have a hover suit, okay, thank you. I got one nod. I was trying this at one point, it's like, you can't do it. I'm like, great. But what you can do is you can use Casper.js to actually move. What it's doing is within that Phantom.js browser, you can't see it, but it's actually moving that mouse around in the page, like an actual physical mouse on the page. So when it gets over something, it's actually going to invoke whatever that hover rule is. So when we undo that rule, we can find one more error that we had completely missed and hadn't even talked about, was the fact that one of our URLs that's supposed to, I can't remember if it's which one it is, it's supposed to have an underline. I think it's supposed to have an underline when you hover over it. And unfortunately, there's no more underline because somebody made some CSS change somewhere, and unfortunately, we don't have web components, and we get that failure. So when we go look to our button's supposed to look like that when we hover over it. Unfortunately, it looks like that. Let me guarantee there's no underline under that one, and there's now a diff. And if I could zoom in, I really wish I could. Come on, Sublime Text, you're failing me. But we caught that diff. We caught a difference of a pixel difference line underneath an anchor tag. And those are the kind of things you can catch with visual regression testing. So last one we're going to do is even more fitting considering the event that just happened a couple days ago. And you'll find out why. All right, so the problem is that we've got a blog, and the blog has, let me get down there on comment. The blog has, content can change. So you never know what kind of content's going to be coming through that blog. I mean, this is the exact reason that we typically try and do our testing on something static, like a style guide or something like that, or some API, like a dummy API that we can mock and be able to bring in. But in the case that you can't do that, or you need to work with some kind of, we need to work with the actual live site, and that's where the testing, the value of testing comes in. Okay, sweet, doing good in time. One great thing about these scripting libraries is that they allow you to inject JavaScript directly onto the page. And you're like, okay, so what does that mean? Well, with JavaScript, we can change content, can't we? So we can easily go into our page, swap out the content that is there for our own content, which means that after this one JavaScript function runs, our component, in this case the blog post, is going to have the exact same content every single time, regardless of what blog post actually came out last week. So as you see here, we've got a title of where we're going, we don't need roads. It's going to be published on October 21st, 2015. It's got a comment count of 1.21. And there's that word again, heavy. Why are things so heavy in the future? It is written by Dr. Emmett L. Brown, whose position is doctor. And apparently I've comment counted in there twice. That's odd. I won't change it because apparently it's been working ever since. And an image tossed in there as well. So I've got this little jQuery function in here that's just going in, swapping out all the content that is there for some stub content. We've done other situations where really all we cared about was the layout of a page. So we'd go in and just like hide all the content, set fixed heights on things, and then take a screenshot. Whatever you want to do to the page before you take a test, it's going to be consistent every single time you run this test. So you can make changes to it, that's fine. It allows you to create consistent environments to make those tests. So now, when we run our tests, and hopefully I actually saved it, good, all right. Done that a couple times. It's going to run through all of our tests, and for our blog one, it's going to find no problems. All right. Blog, because we've got Dr. Emmett Brown filling in for whoever our latest blog post author is. So by using these execute functions, we're able to get into the DOM, we're able to basically massage it to the state that it needs to be at before we can actually do some consistent visual regression testing on it. Whether it's Casper.js, whether it's WebDriver IO, or there's a number of other languages that allow you to do this as well. This is the kind of power that you have when writing tests. And this is where it gets to be kind of fun, is that you get to figure out like what does this component need for test coverage to feel confident that I've covered all the bases? What do I need to do to know that this thing's got 5 different variations, I've covered all of them, what are all the use cases this could be in, I've got sufficient test coverage on this component, I feel confident that it can go out, we can make code changes on it, and there won't be a problem. So writing tests, it's a good time. So, and actually I realized there's one more slide I was going to throw in, but I did not. But this is a good little link, just set of links to all of these things I've been talking about. The last thing to kind of talk about is, well, what happens when there is a change? Because obviously, what we do as developers is we change things. We write new CSS, we change markup, we write new JavaScript, those types of things. We expect eventually to have diffs in our images. So say if I go back to, and actually just let me dive out of here. Yeah, say we go back to this and change the size of the image, or just change the color of the title or something like that. If that's my job to do that, then I'm expecting that to be different. If I change the color to orange for the title, I'm expecting when I run this test to get a diff. And that's good, because it means the change I did actually took hold. What you need to do at that point then, if you are running a diff-based system, is when you are pushing if you work within feature branches, you got a feature branch of code that says H1 is now orange. So here's this code, some CSS or Sass that says my H1 has changed. What that also means is you need a new baseline as well. So these baselines can get committed into code. They can get pushed off into other repos and referenced. There's a bunch of different ways you can handle those assets. But basically what needs to happen is whenever you push that code that says this title is now orange, it needs to be accompanied by that new diff. Basically that truth, that gold standard that says like, this is what this thing should look like now. So that once that code gets merged in, it gets merged in with that diff as well. So the next person runs the test, they get a passing test, because they're now using your new CSS that has yellow H1s, and they're now using your new baseline, which has that in the actual image. So that is the workflow when you're working with baselines. Anytime you make a change, you're expecting those diffs to occur, but you're only expecting the diffs to occur in the things that you are actually working on. So the gotcha here is I'm working on this H1, I'm changing it to orange, it's great, I run my tests, and 3 other things come up with diffs too. Other H1s have turned orange. I'm like, oh, cool, commit, push, yay, merge. Except for the problem is there's these 3 other new baselines that are being merged in with my branch as well. That's a really quick red flag to go like, hey, were we planning on changing all of these things? Or were we just trying to change that one? And at that code review time, you can actually take a look at it and go, are all of these new baselines correct? Are these how all these things are supposed to look or not? And you can then go back to that developer and say, hey, you need to make sure that your styles are only applied to this one place. Or maybe go back to the user story and say, we actually want to change all of these components instead of just one, so you have a better paper trail. But that's the idea of complete coverage on your components, so that when you make those changes and get that diff on one component, you can be confident that that's the only diff in your entire system and nothing else has changed. All right. So with that, go forth and test, and I'd be more than happy to answer any questions. Thank you.